In section 6.2, we're going to focus on representations of functions. So these are all going to be those special relations where every input is going to have exactly one output. This section will go over rules of functions, how to show a function as a table, and also how to show a function as a graph in a coordinate plane or a Cartesian plane. In this video, I'm going to take you through what the function rules are and how they work, and how then to use a table to evaluate the function with specific inputs. And then in the next video, the part 2 of 6.2, I'll show you how it works with the graph. So a function will be based on a function rule, and the function rule is basically a comparison, and what it does is it compares every output to the input, and it always is going to be by the same operation or operations. So if you look below on this screen, you're going to see 3 different function rules. All of them are using the word is, and that's a very important word because in math the word is going to tell you where the equal sign goes in your function rule or your equation. So also we're going to use the variables x and y to represent the input and the output. And since input comes first in the function, and since x comes first in the alphabet, we're going to use x to represent the input and y to represent the output. So when we translate this English into math, we're going to get y is, so there's your equal sign, 3 more than the input. So whenever you say more than, what operation does that talk about? Well, in math that's going to be addition. So we're going to write a plus sign there. Now, when you say 3 more than the input, I want you to think about, what are you starting with? Are you starting with 3, or are you starting with some number that's your input? And basically you're going to be starting with that input number. So even though in English the 3 is coming first, when we write this in math, we're going to write the x first and then the 3. And you know by commutative property that when you trade these, it's not going to make a difference. But this is really the accurate translation from English into math. It's going to be the idea that whatever you start with, the output is going to be 3 more than the input. So let's take a look at the next one. Again, there's your equal sign for the is. The output's going to be the y, and then the word 2 becomes the number 2, and then it says times the input. And you know that whenever you have a number right next to a variable without any sign in between them, then that is an invisible multiplication. So this shows you that whatever number is your output is 2 times the input number. Now if you take a look at the last one is going to be back to what we were doing with two-step equations. So our output is 3 more than all of this. So instead of, if you go back to the first equation where it said more than the input, this time it's going to be more than 2 times the input. So that means that we're going to start like we did before, writing a 2x. So now we can say that it's going to be 3 more than 2 times the input. So if you look at the first and you look at the third, you can see that the structure is going to be the same. You're starting with some input, whether it's an x or a 2 times the x, and then you're getting 3 more than that. So now let's take a look at how we're going to work this out with some tables. Here's a function table where you can see it has 3 columns in it, and we're eventually going to get rid of this second column here with the function, but because that's going to become mental math for you with most functions. So if you look at it, we'll focus on, first of all, this input table. And the input column. And the input column can actually have any numbers you want. So I've just chosen 0, 1, 2, 3, and 4 but you could use 0, 10, 20, 30, 40. You could skip around. You could go 0, 1, 3, 8, 10. You can use negatives, you can use fractions, mixed numbers, decimals, anything you want. So I'm just starting with five basic numbers, the five smallest whole numbers. So what we're going to do in this middle column here, the function column, is we're actually going to plug in the input number for the x. So over here, I'm going to be writing the function down, y equals, but instead of the x, I'm going to write the input value that we're working with right now. And then I go back and I write plus 3. So now we get 0 plus 3 equals 3, and so that's going to be the output. Now, a lot of times you actually don't even need to put in the y equals. I just did it to kind of show you how it's following. So in the next few, just to save time, and you can do this in your work also, I'm going to leave out the y equals. I was just trying to show you how you get the output. So let's do the next one. So instead of the x, I'm going to write a 1, and then I'm going to write the plus 3, and back to first grade, 1 plus 3 equals 4, and so there's the 4. I do the next one, and again, what you can actually do is we could just write all the inputs down at once, because that's what we're starting with. We're going to add 3 each time, and then we do the arithmetic, and we get our output answers, so 5, 6, 7. And that's what a completed function table is going to look like. You're going to have all your input values, all your output values, and again, because it's a function, you'll notice that each of these input values has exactly one output value. So you know if a 2 goes in, that 5 is the only thing that's going to come out. It's a function. So on this one I left out that middle column because again this is sort of an easy function. You're just going to take your input and whatever number you put in you're going to multiply by 2. So pause the video, write in the output numbers, and then resume the video. So 2 times 0, 0, 2 times 1, 2 times 2, 2 times 3, and 2 times 4. And there's your completed function table. So this function is going to be a two-step one, where you're actually going to be starting by multiplying your input value by 2, taking that answer, and then subtracting 5. Now this is the example of, because it's a two-step function, if you wanted to, you could have a middle column that is the function, that shows the function in action. When I do it, I'm going to write out a couple of them for you over here on the right side, just so you can see how it looks. But what I want you to do first is try this on your own. Plug in the 5 input values, get your 5 output values, and then resume the video. So on the first one, we've got 2 times 0, so it's 2 times 0, and then we're going to subtract the 5. So that becomes 0 minus 5, so the output is negative 5. On the second one, for a 1, we've got a 2 times a 1 this time, and then we're going to subtract the 5, and so our answer is 2 minus 5, which is negative 3. When you plugged in 2, you should have gotten 4 minus 5, and that's a negative 1. When you plug in 3 times 2, you get a positive 6. So when you subtract 5, you get a 1. And last one, when you plug in the 4, you get 2 times 4 is 8. Minus 5, you're still positive at positive 3. And there's your completed output table. So for this one, it's almost the same as the other one, the one you just did, except this time I've made that coefficient here a negative 2. So you're going to start by multiplying the inputs by negative 2, and then you're going to add 5. So pause the video, do all 5 of these, and then come on back. Okay, so first one, you've got this negative 2 times 0, which is 0. So the negative didn't matter. We still get 5 as an answer. For the second one, we've got, and I'll put this one on the side for you just so you can see how it looks. You've got a negative 2 times the positive 1 is your input, and then you're adding 5. So this negative 2 times the 1 is going to give you a negative 2, and so when you add 5 to that, that pulls you back into positive, and you're at 3. If you look at the next one, you're plugging in a positive 2, so you've got that negative 2 times your positive 2, and then you always finish by adding the 5. So this time when you look at it, we've got this negative 4 here. So if you owe 4 and you add 5, are you positive or are you negative? Well, you're still positive, but barely. Now if you look at this, before we go any further, I want you to notice what's happening this time. On the earlier slide we did, the outputs, as the inputs increased, the outputs also increased. But this time, look what's happening with the outputs. The outputs are decreasing. So what's causing that to happen? Well, in this function, it's because you're multiplying by that negative 2. So that means that as your inputs get larger, your output gets more and more negative, and so that's what's dragging it down. You're still adding 5, but you're starting out deeper in negative territory, and you can see that even here. You've got a negative 2 when you plugged in the 1, but when you plugged in the 2, you're down deeper into negative 4. So we go back to the chart, and we know this is going to keep going further down. You plug in the 3, and you're going to get, and I'll just sort of skip the step on this, you're going to get a negative 6, the negative 2 times the 3, negative 6 add 5, and if you're starting 6 down and you're only coming up 5, you're still going to be in negative territory, but not by much. Last one on the chart, you're plugging in the 4, so this time we've got the 4, we've got negative 2 times the 4, which is negative 8. Remember, you're going further into negative territory, but you're still coming up that same amount. You're just coming up 5, so that's going to pull you to negative 3. So that takes you through the relationships. This is all called evaluating a function. This is where you plug in input values and you get the output, the corresponding output values. So that's evaluating functions by using a function table. So at this point, go to the problems on that are posted for you in Edmodo and do just those problems so that you're comfortable with using the tables. Ask any questions that you need to, and then go back to Edmodo and pull up the video for 6.2 Part 2, and that'll take you through all how we graph these.